This is a cube, right? This cube is of age 4 centimeter. Okay, it is a cube of age 4 centimeter. All sides are 4 centimeter each. Now my question is little different than this cube. If I suppose if I cut the cube like this, if I cut the cube like this is the surface. Are you able to understand the geometry? The cube is cut by this plane. The given cube is cut by this diagonal plane. Can you imagine the geometry? Given cube is cut by the diagonal plane. Given cube is cut by the diagonal plane. Given cube is cut by the diagonal plane. Suppose I am giving the name of the plane like A, B, C, D. Can you imagine the diagonal plane A, B, C, D dividing the cube into equal half, right? What will be total surface area? What will be total surface area of each half after dividing the cube? Yes. Can you tell me, once you divide this given cubical block in two equal halves and you are dividing by the diagonal plane ABCD, right? Then once the division is done, once the diagonal plane cuts the cubical body, the two equal halves are found, right? So how many faces and what type of faces you will get in each part? First, with the help of the diagram, mark those faces. How many faces and what is the type of the face? Either the face is a rectangle or square or triangle, or what kind of a circle, what you are finding those faces of each part. First you need to identify that part, then only you can calculate the area of those surfaces, right? So what do you think, that once this cubical body is cut by this diagonal plane ABCD, the plane divides cube into two identical portions, right? Yes or no? So based on the portions found, how do you identify each portion with its faces, with its surfaces? Like in case of cube, when we are discussing about cube, we know that all the surfaces are square surface, right? In a cube there are 6 identical surfaces, yes or no? In a geometry of cube, there are 6 identical surfaces. Each surface is a square plane. 4 into 4, 4 into 4, 4 into 4. Each one is a square plane. So there are 6 equal surfaces. Square planes are there, forming the total surface area of a cube. But once the cube is cut by the diagonal plane, as I have marked it as ABCD, do you think that the newly formed two portions, do they all possess all identical surface areas? Come on, yes, Shayanvita. Do you think that each part will have all identical surfaces?
There will be 3 square and 2 triangles.
No. See, if I draw the, what happened? If I draw this, redraw this diagram, okay. If I redraw the part, each part, what is found, that is this one, right? Yes or no? This is the one part of the cube after division. This is A, this is B, this is C, this is D. I can suppose mark this as E, this is F. So you can see surfaces, this total. Now after doing this division, there are two square plane, there are two square planes. What are those square planes? The square planes are, I can name them A, B, E, F and C, D, F, E. These two are square planes, right? One rectangular plane. Why I am calling it rectangular plane? Because ABCD, definitely this is 4, right? But this length is not 4. Do you think that it is 4? I don't think. Is it 4? No. Because this side is 4, this side is 4. How can this also be a 4? Because ADF is a triangular geometry. Right angled triangle, yes or no? So the rectangular plane ABCD. So the rectangular plane ABCD is concerned, it can be drawn like this. This is ABCD. Of course, this is 4 centimeter, this side is 4 centimeter, but we do not know the length of AD and BC. We can definitely calculate the length of AD and BC. How can we calculate AD and BC? Because in triangle AFD, check it again. In triangle AFD is a right angled triangle. Yes or no? Right angled triangle, right? So AFD is a right angled triangle where I can write down AD square is equal to AF square plus FD square. Yes or no? AF and FD both are 4 each. So 4 square plus 4 square. So this is 32. So AD will be equal to root under 32, means it is 4 root 2 centimeter. 32 can be written 16 into 2. 16 can be taken out as its square root of 16 is 4. So it is lengthwise 4 root 2 centimeter. Are you getting me or not? So that's why ABCD is not a square. Pardon? Is it okay? So that means rectangle plane ABCD is known by both sides. One side was earlier known as 4 centimeter. So now I can say about the length AD, which is 4 root 2 centimeters. So this will help me to know the area of the rectangular plane ABCD. So that means I know the area of three surfaces, two square planes and one rectangular plane. Apart from this three plane, we are having two more planes, those who are triangular plane. And the triangular plane are AFD and BEC, right? Triangular plane are AFD and BEC, right? They are right angled triangle. AFD and BEC are right angled triangle. So you must be able to answer the area of right angled triangle, isn't it? So that means, therefore, area of each right angled triangle, that will be half base into height. So I know about the right angle triangle like this. I can say this is A, this is F, this is D. The adjacent side AF and FD are perpendicular to each other. Both are 4 centimeter each. I can take them. The mutually perpendicular sides are known to be base and height respectively. Right. If I take AF as the base, I can refer FD as the height. Yes or no? So that means this can be written half into 4 into 4. Right. So that means 8 centimeters square will be the area of each triangular portion. So there are two such triangles. So total surface area, as per my question, total surface area is coming 4 into 4 is the surface area of a square plane, and there are two such square planes are there. So I can write down it is 2 into this, 2 into 4 into 4 plus rectangular portion is 4 into 4 root 2 centimeters square, and there are two triangular area each of 8 centimeters square. So there are two triangles, isn't it? You follow? Tell me yes or no. The total surface area of the each part found after cutting the cubical geometry, whose total surface area will be the value of this, whatever you get in calculation.
Sir, would you mind sending me some questions on the topic how to find the cube?
Okay. I will send it. I'll send it tomorrow for all of you. Okay.
Okay, sir.
Yeah. Sure.
Yes, sir.
Okay. an interesting question, tricky one. I have said that a solid cylinder of radius 1 centimeter and length 4 centimeter is made to roll on a horizontal surface. Then find the surface area of that horizontal surface through which it is moved. It is moving forward, through which it is moving forward into complete rotation. I can help you by giving a related diagram of this. For example, let this is be the cylinder. It's a three-dimensional geometry. You can understand it like this, right? So this is the horizontal floor or the horizontal surface. Okay, this is the horizontal surface on which, if this cylinder is made to roll in this order, the cylinder will definitely roll on the horizontal surface, right? We can see the cylinder supposed to have moved through this distance. Suppose the cylinder will be moving forward through a certain distance after completing two rotation of it, right? Cylinder will be expected to be moving forward after completing two rotation. So this is that cylinder. Now question arises if the cylinder is made to roll continuously on this horizontal surface. The radius of the cylinder is known, the length of the cylinder is known, right? So if this is the initial position, of the cylinder before it starts rolling, and if this is the final position, so my question is the surface area through which it is moving, means I'm talking about this area to know. I'm trying to know about this area of the surface through which this cylinder is rolling and moving forward, right? Isn't it? If you are given something, suppose you are having a water bottle which is absolutely cylindrical in shape. You can right now you can do the experiment wherever you are sitting. Suppose with a cylindrical water bottle, if you try to roll on a horizontal tabletop, right? So definitely with during the rotation it will definitely move forward, yes or no? Are you all able to understand me? Shainvita, Yash, Shaindri, Shirsha, are you all able to understand my question? So I want to know that once it will complete two rotation, once the cylinder will complete its two rotation, then during the process of rolling, it will keep on moving on the horizontal surface. So this is the horizontal surface through which it will move in this process after completing two rotation. So I want to know about this area. So at least with my drawing you can understand what kind of area will be through which the cylinder is moving forward on horizontal surface. Isn't it an interesting question? Yes, Shainvita. Aindri.
Yes, sir.
Okay, are you attempting it? Who can tell me? Who can tell me the meaning of two rotation? What will happen? How will you reach to the conclusion with this term of two rotation? What will happen about the one rotation measurement? Suppose when the cylinder will complete one rotation, then in one rotation by what distance it will move forward? Anybody can tell me, in one rotation by what distance the cylinder can be expected to be moving? Because in the process of rolling it is definitely moving forward. That's why I have marked two distinct position of the cylinder, initial position and final position. So definitely in completing two rotation it is traveling through something, a distance, let it be x, right? So I want to know that if x is assumed to be the distance it has moved in two rotation. So I want to know that how much it can travel, in the process of completing one rotation.
Sir, it will be twice its radius, right?
No, write down every circular cross section. I'm generalizing it, not only for cylinder. The same argument can be done, same question can be raised with the geometry of a ring, geometry of a disc, geometry of a sphere. So every circular cross section, are you understanding the meaning of it? This is the circular cross section. Okay, this is called circular cross section. So a ring is also possess circular cross section, disc also possess circular cross section. So every circular cross section travels linearly a distance equal to its circular cross section, equal to its circular circumference during its one rotation. Are you getting me? The time during which any circular cross section body, either it is a ring or a disc or a cylinder, by what distance it will travel in the journey of completing one rotation, it will travel forward equal to 2 pi r, because its circumference is 2 pi r, isn't it? What is the circumference value of the circular cross section? What is the circumference measurement of a circular cross section? Isn't it 2 pi r? Yes or no? Tell me. Perimeter of a circle, circumference, that is called circumference. So what is the perimeter of a circular cross section? That is 2 pi r. So that means in one rotation it will travel through 2 pi r. Let this is 2 pi r. In next another rotation it will travel through another 2 pi r. Are you getting me or not? So the distance through which it will move forward during the process of rolling, okay, whenever a cylindrical body will be rolled on a horizontal surface, in every complete rotation it will move forward by a length called 2 pi r. Got my point? So I have asked about the surface through which, the surface of the horizontal plane through which it is moving forward in the process of two complete rotation, means in completing two rotation it is moving forward through 2 pi r plus 2 pi r. It is traveling total how much? 4 pi r, and its length is involved in the process. So this shaded region, isn't it a rectangular surface? Yes or no? Tell me the shaded region of the horizontal plane through which it is moving forward during the process of rolling, that is a rectangular plane. So here I can write down, if every cross section travels linearly a distance equal to its circular circumference during one complete rotation, that is equal to 2 pi r. So the surface area the surface area of horizontal plane so the surface area of the horizontal plane through which the cylinder will move in two complete rotation is a rectangular region, right? That is a rectangular region. That rectangular region can be marked like this. This side will be the L, that is length of cylinder. This side will be L, right? That is length of cylinder. And as I said, this side is x, this is 4 pi r, the distance traveled. So ultimately this rectangular region through which it is traveling is this one, whose adjacent sides are known, one as the length, which is already mentioned, I think it is 4 centimeter, yes. So length is 4 centimeter, radius is given, means you can calculate 4 pi r. So therefore required area, that will be equal to 4 into the 4 pi 22 by 7, radius I think 1, this much centimeter square, isn't it? Tell me yes or no, could you follow this argument? Who could not make it up to the mark, tell me if any doubt, if there is any doubt in this discussion. Yes, Ainri, Shanvita. A cylindrical pipe of length 8 centimeter with inner radius 2 centimeter and material thickness 2 centimeter, right? Find the ratio of its inner curved surface area to the outer curved surface area. Are you able to analyze the geometry? This is the meaning of a cylindrical pipe. Okay, this is the material thickness. This is the material thickness which is given, and its inner radius, suppose small r, that 2 is given, along with the length is also given. It is 8 centimeter. Length is given 8 centimeter of this cylinder. Its inner cross section is given. It is having material available in it, right? It is not entirely solid. You can draw a dotted line like this. So this is that material part. This is the material part. Inside is definitely empty space. So a cylinder, if it can be visualized, it is something like this, right? So its material is having all in its cross section. Everywhere the material is having its thickness. So inside is a this much line. This is the empty space, right? You can imagine the axis of the cylinder that can be drawn like this. This is the axis of a cylinder through the center. So a pipe can be visualized like this. Okay, a cylindrical pipe with the material thickness known by its inner radius, known by its material thickness, known by its length, and then you need to know about the ratio of the curved surface, importantly curved surface area. Ratio of the inner curved surface area to that of the outer curved surface area. That ratio you need to know. Yes, yes, Shanvita, have you done it? What will be the ratio? Do you think that in finding ratio, will the length of the cylinder will make any issue? Yes or no? Will it make any effective role in finding ratio? First of all, can you tell me the formula of curved surface area of a cylinder? What is the formula of curved surface area of a cylinder? Correct, 2 pi RH. See, as the inner radius is given, with the inner radius, if we add the thickness, can't we get the outer radius? Correct. So, as the thickness is given, thickness we know, let it be T. Okay. Let the thickness is known to us as T. So, inner radius with thickness will be the outer radius. So, outer radius will be inner radius plus thickness, right? So, inner radius is given 2 centimeter, thickness is also 2. So, that means outer radius is 4 centimeter, right? So lengthwise, either it is for inner surface or for outer surface. Length will be same. Length will be same. Length will be same for both inner surface as well as outer surface. Yes or no? Length will be same for both inner surface as well as outer surface. So that's why we can write down the surface area value. So therefore surface area, curved surface area rather, curved surface area of inner surface, that will be equal to 2 pi in small r into L, because inner surface radius is smaller and curved surface area of outer surface, that will be 2 pi capital R L. Are you getting me or not? Both the surface area calculation is concerned, that definitely depends on the parameter length of the cylinder, but required ratio, as I have asked about the ratio of the inner surfaces to outer surface, curved surface area. So that ratio will be 2 pi small r into L by 2 pi capital R into L. So ultimately 2 pi L will be cancelled out and it will be small r to capital R. The ratio will be found by using the inner radius to outer radius only, because had it been asked about the calculation of the inner and outer surface area, then we should have calculated the value according to the formula 2 pi RL for both of them. But as because we have been asked here to find the required ratio, so we'll divide the inner surface area to the outer surface area, and then it is small r to capital R. So it is 2 by 4. So ratio is coming 1 by 2 or 1 is to 2, right? Isn't it? So that means outer surface area is twice that of inner surface area, isn't it? The outer surface area, outer curved surface area is twice that of inner surface area. Can you tell me, though primarily this is not asked in the question, but still if I add one part in it, that is what is the material volume? What is the material volume of this pipe? Can you answer this? Can you find the material volume of this cylindrical pipe if I add this question in it? In the same data where the inner radius is 2, material thickness is 2, length is available as 8, what will be the material volume? Material available as a cylindrical pipe. So what will be that material volume of this pipe? Who can give me the idea about finding the volume of a cylinder? Volume of a cylinder. What is the volume of a cylinder? Anybody? No. Simply pi r square h, cross section into length. Okay. So volume of a cylinder will be pi r square h. Volume of a cylinder is equal to pi r square h, right? This is a basic formula. So material volume will be outer surface enclosing volume minus inner surface volume. So therefore material volume will be outer volume means outer surface enclosing volume minus inner surface enclosing volume, right? So that's, we can in general form we can write down outer volume minus inner volume. Are you getting me or not? Outer volume means outer surface, so outer surface cross section will be pi into capital R square will be its cross section, that into length, right, minus inner surface cross section will be based on radius small r, so pi r square into L. So material volume will be outer surface up to outer surface enclosing volume minus inner surface enclosing volume. So cylindrical portion's volume is measured its cross section into length. Length is only said to be h, right? So you know length, you know capital R, you know small r as well. Okay, so substituting the value pi into capital L, you can take common that into r square minus small r square. So you can calculate it pi as 22 by 7 into length 8 into this is 4 square minus 2 square. This much centimeter cube. Material is the volume, centimeter cube will be in unit. So simplify this calculation. It is 22 by 7 into 8 into 16 minus 4, that is 12. So 22 by 7 into 8 into 12 centimeter cube. Whatever it comes, that will be the material volume of this cylindrical pipe.